welcome to our paper video abstract for the highly efficient wideband mmWave Rectennas for wireless power transfer system with low-cost multi-node tracking capability, published in Attribute Transactions on Antennas and Propagation. In this paper, we have presented a new system, a brand new system for the wireless power transfer using the mmWave high-frequency signals. Compared to the traditional wireless power transfer system, our design can achieve the remote charging and adaptive charging for different devices simultaneously and tracking their locations. And importantly, we have using the high-frequency mmWave power. So compared to the low-frequency power, our mmWave power can achieve a better antenna aperture efficiency, higher gain, and a number of advantages we have summarized in our paper. And the most important contribution for our paper is basically we have used a new system to replace the traditional beamforming phase array, which is high cost and high power consumption at the mmWave frequency band. We use a liquid antenna transmitter, which can produce multiple beams and scanning as a function of the frequency. And in our system, so we have actually demonstrated a 3-node system. So we can use the frequency scanning liquid antenna and then a feedback signal from the receiver to tell the transmitter which are the optimal beam locations to perform the frequency modulation. And then the node tracking, we have used a frequency swiping algorithm as a function of time. So we can swipe the frequency at the transmitter side, and then we monitor the rectified DC power of each of the receiver. And then we can identify the optimal time instant when we produce the highest DC voltage, and then we tell the transmitter which are the time instant to produce the frequency as a function of time. Then we can perform the multi-node frequency modulation for passive beamforming. This is our main design, which is a wideband mmWave Rectenna, and we use ME dipole, which has a wide bandwidth and a wide beamwidth. And then we co-designed ME dipole with the rectifier without using a wideband matching network. Basically, we study a high-frequency semiconductor GAS diode, and then we both studied the nonlinear wideband impedance from 16 GHz to 40 GHz for both antenna and rectifiers. The co-design performance will tell us the Rectenna has achieved high conversion efficiency and wide bandwidth for the mmWave band. Due to our co-design, we eliminate the loss at the mmWave transmission lines. And from the testing results, our system have demonstrated a very high efficiency in the frequency band and the power range of interest, and a very robust receiving capability for different incident angles. And this is an example of our transmitter, a single liquid antenna, and then we perform a multi-tone modulation for the signal source using the amplifier to transmit 3 beam together to track and charge 3 multiple Rectenna nodes at the same time. So this is our system. We use some kind of power amplifiers and also the DC power sensor based on the Bluetooth gateway to tell the transmitter the kind of beamforming information control. And compared to the state-of-the-art, our system has a number of advantages in terms of the bandwidth efficiency and also the innovation. Thanks for your listening.